these models say?
Yeah. Yes, the one which is most problematic for many learners, it's this one and solid state. Isn't it? You guys you don't do nuclear physics.
Yeah.
Yeah, you don't do that one. Those are the three modules. There is nuclear, thermodynamics, and there is quantum, solid state. Those are the giants of physics.
And so solid state, the assignment is carrying like 35 and then exam is 65. So if we push on the assignment, we have like 6 assignments.
Yeah, you must push on assignments.
35 is a lot of marks.
It's a lot. I will pass. Passing, you will pass. You pass.
I have to do my own. I don't want to just pass.
Yeah, you don't have to go to SAP. SAP is boring. So SAP, we need now is another year. There you are. You see, just pass it once. The year end, then you are done. You don't have to. Let me get the screen.
It said it was recording, but the screen is not sharing yet. I don't know what happened.
I had not pressed share.
So do you assist learners who are doing honors in physics?
No, now I for honors it's only assignments and projects. I don't tutor now. You just pay for the research project, it can be done for you, but they don't pay 400. We charge thousands of rands. The minimum it's 5 for honors, those who want their research projects to be done. We don't charge 400 rands, 100 rands, because I was just doing you with the Clementine just to push you and assist you guys since I started with it last year. But your time slot, there are many learners who want to join this time slot. So I was even thinking of refunding you. Then I say, let me refund you. I take these guys. But I just felt like at least it would be.
Who would we be without you saying with this Ayo?
So that was my idea. So I just felt like let me just help these learners. All right. Let's start. Is the screen sharing?
Yes.
All right. So these ones are friendly questions. They are not that much difficult. Assuming that a star, so today is just a warm-up, we are not pushing that much so that I compile. But the questions, these ones are just theoretical questions. They are easy to understand. Once you get a formula physics, some of them get a formula like what we were doing last time, you can maneuver through. You don't need much of theory behind. So assuming that a given star radiates like a black body, so estimate the temperature at its surface. So you have to estimate the temperature at its surface. So you need information, the formula. Physics is all about formula. So first you identify which formula are you going to be using. So on this question, for intensity, it's I. So I is equals to, from the information sheet. I did not check this one, information sheet, if the value was given, but normally in exam, they give you I stands for the intensity. So I is the total intensity. I will give the compiled solutions where it gives the definition. So Y is intensity, where it's given in megawatts. So capital letter M, it's megawatts. MW, it's megawatts per meter square. So that is your intensity I. So it's megawatts per meter square. Now, we want to calculate the temperature. So we need a formula that will assist us. So this intensity I is given by that constant, which is the Stefan constant, Boltzmann constant, which we are going to give you multiplied by the temperature to the power 4. Multiplied by the temperature to the power 4. So that sigma line sign, which is like this, that sigma sign, it's what we are referring to as the Boltzmann-Stefan constant. So once you have the intensity, then you can calculate the time because we know what that is. So for number 1, we have those two formulas which I have given you for number 1. Then you can start compiling your assignment already. So we said I is given as 575, which is megawatts per meter square, the intensity. I is for the intensity. And you can also convert it into standard form, which means if you want to write it into scientific form, your calculator can convert it which is just 5.75 times 10 to the power 8 watts per meter square. Then using your formula, which is going to assist you to get the temperature, you must know what is this constant, which is the Boltzmann constant, the Stefan Boltzmann constant, which means this is 5.67 times 10 to the power of negative 8, which means it's watts per meter square, and then multiplied by Kelvin to the power 4, Kelvin temperature, which means the scale is not in degrees Celsius. So which means also your answer there is not going to be in degrees Celsius, but it will be in Kelvins because of that K, which is there. So the M is standing for the meter square. The K is standing for the temperature to the power 4. So this is that constant which I have given you. Then what is left out is the equation now. So this is the very important. You must be now forming that equation, your book formula sheet of equations, which you are not given in an exam. So these equations, you don't get them in an exam. You must know them by heart. That's sigma T to the power 4.
Yeah.
You are not. So like what we did last time, they don't give you formulas. So this one already, you put it as your toolbox, which is going to assist you.
So
So
say,
yes,
sorry to those values that you gave us, all
yes.
they're constant, all of them.
No, for the intensity I,
Mm,
it's let's go back
okay.
there. Right. So for the intensity, are you seeing the intensity there?
Yes, the I, is it constant? The value.
Yes, the I is given this one, 575 megawatts per meter square. Remember, meter square, you can put a slash or it can be multiplied by m to the power negative 2. Remember, this is dot m to the power negative 2, which means it's meter mw m to the power negative 2. So you can rewrite it if you want, like this, 575 megawatts. Then instead of using that, you use a slash m squared. So it was not a constant. You were told that it emits a total intensity. Emits a total intensity of 575 megawatts per meter square. So the temperature was not given, but we know the intensity. Do you understand? So it's like we are working in reverse. Can you see they are asking us temperature, but they did not give us the intensity at A. So the intensity, now they are telling us that the total intensity is 575 megawatts per meter square. So using our
So
formula, yes, ask.
in A, we are going
Mm.
to use the value that were given in B to calculate to find the temperature.
Yes,
Oh.
yes, yes, yes. because we are still talking of the same star. We are still talking of the same what? Star, remember. A given
Yeah.
star, like a blackboard, estimate, you are still talking about its temperature, and you are going to estimate the wavelength of its longest radiation. All of those depend on intensity. Yes. Any question? Ask
No,
if
so far.
no question. You are having a calculator with you, ne?
Hmm?
You are having a calculator with you?
Yeah, I have a calculator.
Yes. So let's plug in the values. So now we want to solve for t to the power 4. So we are going to make t to the power 4 the subject of the formula. So t to the power 4 is equals to that intensity over the Stefan Boltzmann constant. Then you divide, you see what you are going to get. The answer must be in kelvins. And don't forget also to put your answer as square the fourth root if you are calculating t. So the fourth root of that number. So in other words, we are making t subject of the formula. I will put, so I am saying t to the power 4 is equals to, you take that value of I over that sigma.
The sigma. Okay.
Constant is equals to. So if you want to solve for t, that's why I'm saying you are going to take the fourth root. So in other words, you take t, it will now be the fourth root. Yes, that is the trick there. We are just playing with your mathematics there.
Yes. Oh, so physics is hard, man. Oh.
No, it's not hard. It's just formulas. Once you know the formula, everything is done. That's why I'm saying already pick this formula, put it aside in your book where you're writing our extra class, everything that you are doing online. Then once you put it on a book, when you go for exam, you just recap, they just repeat the same question, they change the values.
Ne? Yeah, like how you told us last year.
Yeah, just same questions, but the different values. Maybe this time they've given you the intensity and you know the Stephan constant, Boltzmann constant. Then next time they will give you the temperature and then
Yeah.
they don't the intensity. Then you are supposed to find the intensity. So they will be
Mm.
just around. Yes.
Oh,
They will
the
be just
formula is important.
the formula,
Mm.
which is important. You don't cram numbers, but you know the formula. Yes. So calculate T and just see what you are getting. I just want to check the answer questions if you are able to punch and press your calculator correctly. Because here it's not a matter of now knowing, just a matter of are you able to press your calculator correctly. That's all. That's what I want to check. So if you give me the correct answer in kelvins, there all the values are there. Just a matter of how you are going to be pressing the values in your calculator so that we can check. What value of t will you get? We are not winning.
the this Q, because now I got 1,014, and then I have to put the root 4. Ish, this calculator.
Yeah, that's what I want to see, because you find that you lose mark because yet it's not the problem is not that you did know, but the way you were pressing the calculator. See, so that's why I want to check so that I can see that for sure this calculator it's reliable.
Yeah. I lie. I have to get a new calculator.
So you see, marks will be going because of a calculator.
No. It's because when I punch the root,
Hmm.
I shift right the root. It gives me the x. When I write a number, 4, the square
Hmm.
root disappears.
Which means the calculator which you are using is the old one. The new calculator, that one, it just put the fraction, the number on top, the number below. All right, you do it on your spare time.
Okay.
But that you're supposed to get should also be when you do it. T should be approximately 1 comma 014, like what you indicated.
Yeah.
But it's multiplied times 10 to the power 16 times 10 to the power 16. The units are kelvins. In physics, normally, always our numbers are accompanied by units. So calculate. So whereby if you round off, then the T you can, depending how many decimals, it can be 1 comma 0. If you want to do 2 decimals, 1 comma 01 times 10 to the power 16. Any question?
That answer you got it after putting the root 4 of the value that you got. The T.
Yes, there's a mistake there. Let me rectify it.
Because
All
I
right.
think that's what got when I was dividing.
So which means when you, before you divide, isn't it? This is
A.
t to the power 4. So
Mm.
which means t to the power 4 is this value. This is your t. Thank you for the clarification. Then you put the root on both sides. So what is the fourth root of 16? So which means of 10 to the power 16. Remember exponents. If I say the fourth root of 10 to the power 16, like this, fourth root, it means just 16 to the power 1 over 4. So in terms of mathematics, this value, you can still verify it by manual, by saying this is the same as 10. This is the same as 10 to the power 16. And everything, I'm applying it with 1 over 4.
Mm.
Means it will just be 10 to the power 4 because you are dividing, or you are multiplying by a quarter, you are dividing by 4.
Mm.
E will be approximately 1 point. Then also you find the value, cube root. You find that it's 0.03, the fourth root of this, times 10 to the power 4 kelvins. Now it's fine. Now it's okay. Any
Yeah.
question?
No.
Yes. Okay. Let's move on. So at least number 1, you are sorted. You have a solution.
Mm.
Yes. Better than you'll be moving bit by bit. You'll be saving time for the other thing. All right. For number 2, oh, sorry, we have B. We have B.
FB, yeah.
Stays B. We are not done. So for B, we are told the wavelength of its strongest radiation when it emits 575 megawatts per meter square. So you need to know the value of the wavelength lambda, and your T, the T, did we calculate the T? Do we know the T now? We know
Yeah, we
the T.
have the T. Yes.
So in order for us to calculate the lambda max, formula, number B, let's write number 1B.
So the screen is no longer sharing. I don't know what changed.
The screen is not sharing.
Mm-mm. So I think something moved.
Okay. How about now?
Still
Yeah.
the same. Is it network?
Yeah, I'm trying to check because I'm here. It's saying sharing, so I'm trying to check.
Okay.
Let me see what is that. That's the only problem with this network. All right. Check again.
No, it's still not sharing.
How about now?
Yeah, it's sharing now.
So for this B, question B, we are going to say for B, what are you looking for? For B, you are looking for the wavelength of its strongest. So in other words, strongest is given by lambda max. Lambda max, which is the strongest.
Okay.
Wavelength, the symbol for wavelength is lambda.
Mm.
So strongest is the maximum. So the maximum lambda, that's where we are getting that information. So we need a formula again. So physics all about formulas, which I need to attempt to solve for this. So we need a formula for that lambda max. How are we going to find the lambda max? How are we going to find the lambda max? So we use the formula lambda max is equals to what?
Is it I over T?
Then the T, you are having it, which is correct. But what is the one that we are going to be using on top?
Intensity.
We call it letter number B. So the B stands for what? So you indicate in your assignment that B is equal to what we refer to a constant, which is the Wien's displacement constant, which is given by the letter B. It's a constant.
Okay.
Can you see that everything is hidden in the formulas? So Wien displacement constant, and that constant, it has a value which will be given on the formula sheet, which is 2,898 times 10 to the power negative 3 meters multiplied by kelvins. So meters multiplied by Kelvin. So that is the constant, and those are the units. So you have your B. In other words, B is equals to that. And then you have your T. The T, we calculated it. What did we find as our T? The temperature which we calculated, we found it as what?
It was 10 times 10 to the power 4 Kelvin.
What was the T?
It was
one,
1,0.
so which is just 1 times 10 to the power what?
Oh,
4. The reason why it's 1,0 is because the 3, remember when you round off, it did not 2 decimals or even 1 decimal place. So it's times 10 to the power of 4 kelvins. Then the question now saying, what is the maximum for the radiation which is going to occur at the, which is going to be the strongest, which is the lambda, the wavelength, where its radiation is the strongest. So that lambda max, that is what you don't know. Then you set up the equation now. You have those two quantities, BT and your lambda max. What is the equation? That's where the physics is. Once you know those formulas, you are done. But if you don't know the formulas there, then you become stuck. That will be the end of it. So there you just need to find a formula that gives you the relationship between lambda max and that Wien's displacement constant. So the formula, it says lambda max is equals to that B over T. Or the original, you can take it as it is to say lambda max multiplied by the temperature. This is the original equation, is equals to that constant, which is the Wien's constant. So the Wien constant is the same as the lambda max multiplied by the temperature, but solving for lambda max, that's why we rewrite it like this. So if I know B and I know T, I can calculate the lambda max. You want to try to press in or calculate? Or we
yeah.
don't calculator anymore.
Then I can get a new one when we still.
So B over T, put the values. What is B over T? What are you getting? This one is easy. B over T, what I get.
Okay. 28,98.
28,
98.
is the final answer.
Yeah.
It's not being multiplied by anything. Are you sure? Verify again. Because
Okay.
B 2,898 times 10 to the power negative 3. Then on the denominator, T 1 times 10 to the power 4.
I think I didn't put the negatives, the negative sign.
So
No, it's still
check.
giving me the same thing.
Okay.
Okay. 2,898 times 10 to the power negative 3, right? Divided by 1 times 10 to the power 4. Yeah, it's still giving me the same thing.
It's because you said divided by 1 and the answer times 10 to the power 4, which is wrong. So it's divide, then you put that divide in brackets. You understand?
Okay. Let me do it.
Divide. That divide, you put it in brackets while it's joined by 1 times 10 to the power 4.
Maybe.
Because once you say divide by 1, it gives you the answer of dividing by 1. Then you say that answer times 10 to the power 4, which is wrong now, you see.
Oh, 2,898 times 10 to the power negative 7.
Yes, then round it off to 1 decimal. What do you get?
28, that into 3.
Approximately 3, ne?
Yeah.
So the answer is approximately to 1 decimal, approximately 2,9 times 10 to the power negative 7 meters. So in your calculator, once you say a number, if you say 4, if they say 4 divided by 3 times 10 to the power 5. So if you punch in your calculator, it's equals to 4. Then you say divided by 3. Then you say times 10 to the power 5. Then you are wrong. Because this now it implies as if 10 to the power 5 is on the numerator. Yet 10 to the power 5 is on the denominator. That's why I'm saying you introduce brackets here, you introduce brackets there, so that you are being specific. Calculator will still give you any answer, but is it correct or is it, you see? So
it's correct.
Careful there with your calculator. Be careful. But if you say 4 divided by 3 first, you get an answer, times, then it will be meaning the wrong thing. So make sure you do. All right, I have another class now. Let's meet tomorrow. It's what, Wednesday? So tomorrow I will send you the solutions, then the complete solutions, then you can go through them, then we discuss it on what? On Wednesday. Is it fine? I mean on Thursday. Yes.
Please
Is it
don't
fine?
forget to send.
Yeah,
Direct.
I will send it. Don't worry.
Okay. Thank you, sir.